Okay, ready, we're back. Okay, technical issues aside, apologies, we've switched technologies here, so we're on a new platform, as you can tell, Zoom. There might be a few hiccups in today's meeting. Hopefully we'll work out the kinks, everything goes smoothly in the next one. So thanks in advance for your patience. So we have 3 items on the agenda today. We'll go to a wildfire discussion around Corda. One moment, everybody, we're just trying to figure out how to ensure the recording is happening. Okay, carry on. So let's run through a couple of things. First off, we wanted to let you know on the Corda builds, we are still on milestone 14. We are going to do a milestone 15. However, it's only for internal testing purposes. We're getting very close to the 1.0 release. So we're not going to go through the effort of putting out another milestone and disrupt everybody's productivity. So look for 1.0 will be the next milestone build that comes up. The first thing we wanted to talk about in terms of news is CordaCon. So we want to remind you, September 12th in London, we'll have our first full day Corda conference. It is free, and we do have a cocktail reception at the end that we'd love to join. I'd love to have you join us for. Since the last time we spoke, we have our keynote speaker. We're very excited to have Simon Johnson. Simon Johnson is effectively the father of SGX, so he's their technical lead on the team there. So he's going to come give a presentation around SGX, about how the technology has gotten to where it is today and where it'll go in the future. So Simon Johnson is on the technical team and he is very technical, so anticipate a truly technical discussion on that. Along those same lines, we've readjusted the agenda to get even more technical. So we want to bring more of our engineers to the forefront. So you'll hear a lot of technical discussions from them. As well as a couple of external presenters. So we have Mike Kennedy from TIBCO presenting. So Mike Kennedy is going to talk about their cloud bursting capabilities and how they've worked Corda into that technology. So helping even more on the scale. And Marley Gray of Microsoft will be coming to present also, talking about the work we're doing with Microsoft for Azure. So hopefully you can join us for that. Again, it's free, and just go to corda.net to register, September 12th in London. So I want to make a brief mention also, you may have seen in the news, the Microsoft announcement around their COCO platform. So COCO is an acronym for Confidential Consortium. It's work they've been doing around a framework to support distributed ledgers in general. It's a technology that is agnostic of distributed ledgers, so it's not a distributed ledger technology in and of itself. It's a framework that DLTs can leverage. So we're quite excited to be a part of that announcement. You would have seen that Corda is one of the platforms that is supporting Corda, and we're bringing our own SGX work to bear here. So this is a great example of our partnership with Microsoft continuing. So we're doing joint engineering on work on this. Just to set expectations on timeframes, there is no anticipated timeframe yet. The engineering work is in progress, but we have no dates to announce around either beta or general availability. But we'll certainly keep you posted as the work progresses there. So the next thing up, we are going to switch over to Mike Hearn now for Mike's presentation on Corda Post 1.0. We might need a moment to switch over to him. We have to figure out how to give him control. So give us 1 minute. Yeah, we're back. Sorry, guys. So we're just trying to get Mike Kern logged in here. Yeah, it looks like Mike's just joining.
Yes. Do you hear me?
Excellent. Thanks, Mike. We can hear you, yeah. And Mike, let me know if you want me to control the slides on this end.
Well, you know what? Should be okay. Let me share my screen.
I had to stop on my end, I think.
Well, there we go. So you should be able to see my screen now.
Yeah, excellent.
All right. So I think we are there. Okay. So what I'm going to talk after the going to come later, stability-wise, and in what order. And I'm going to talk a little bit about how we're planning and preparing for this, and things that we expect to take a bit more work. Okay. So our goal here is like Java-like stability, which is a pretty high standard. So the goal is to offer full backwards compatibility for public committed APIs and protocols in perpetuity, right? And if Corda is a big and successful project, right, that could be a very long time. And this possibility also includes potential for platform level bug workarounds. So this is not a compatibility, but we're always looking for ways to stab you in the back and get you in small print. This potentially will include cases where you've actually, app developers have made mistakes. Nonetheless, if the app is, systematically important to the ecosystem, then, we might actually work around that sort of thing as well. So this last point, obviously, like any such platform, it's not a promise, but we do want you to understand that we're on your side with this stuff. Right? We don't want apps to break. If people are chatting to me, by the way, then I don't see it yet. I will have to wait until.
I'll cover that for you, Mike.
Okay.
I'm following the chat window. You're okay.
Getting used to this new software as well. All right. So when we release Corda version 1, which we're aiming to do at the end of September, possibly a week or so later, we'll see. Then this will be offering API stability only at this time. What it means is your source code will continue to compile and work as new Corda versions are released. We may still deprecate APIs from time to time and things like that, but we won't delete them, and they will continue working in perpetuity. Right? This is the goal for the 1.0 release. That doesn't mean that every kind of stability that we want is going to make it for 1.0, because some efforts, although most of the work we're doing right now is in the form of compatibility, some efforts are lagging behind a bit and will arrive a short time later. So for that 1.0 release, we won't be offering wire stability, database schema stability, or ABI, that's binary interface stability. Now, that's not because we don't value these things, that's just because a few of the initiatives are, like I said, lagging behind a few weeks, and the 1.0 release is a sort of date-based release. Additionally, we want, what matters right now for most people who are developing apps on their platform but aren't ready to launch yet is the API stability, source compatibility. And we'll go into a bit of detail about what these are. Right? So API stability, it's some of the work we're doing to try and meet this goal in time. We are doing things like reviewing the package module structures to ensure that the layout actually makes sense, and that each package within a module can be given a crisp one-line description. Right? If you've ever looked at high-quality Java docs, you'll know that every package has a brief description of what's in it. Some of our packages are kind of duplicated or a bit messy or a bit hard to summarize. So, we're just moving some code around. This is very easy to catch up if you use IntelliJ. Once you update to a new release, of course, the import lines will break, but just opening the file in IntelliJ, if your settings are configured right, is usually enough for the IDE to automatically repair the code. We are reviewing the way the API looks from Java specifically to ensure that it's idiomatic, that it feels like a Java API. Of course, Kotlin generates Java-style APIs with getters and setters and is methods and so on by default out of the box, but there are still cases where the API doesn't look exactly as a Java developer would expect, and we're polishing some of those. We've also been more cleanly separating core Corda from finance Corda. Now, finance is, of course, the driving motivation for most blockchain work. It always has been since day one with Bitcoin, which was a financial app, of course. Nonetheless, there are use cases outside of finance that Corda might one day be applied to. And as a consequence, having good modularity there and clean separation is a useful thing. So finance is now a Corda app that you would install into your node, and Corda apps can depend on each other. So that's how financial types like the cash contract and so on will be presented. I should mention here that there are some cases where, because we've developed the finance app basically as a way to try out the platform and test it, the finance app won't be a part of the initial stability guarantees because there are some requirements there that we might not have nailed because it's never been, we haven't actually deployed a real national level payment system on top of this app. So it's a little bit early for us to nail down those apps and claim they will never change. We would just end up probably having to throw away the old one and create a new finance app if we did that. So, and then finally, as we've been going and more developers have been coming to Corda, we've been using deprecation even before 1.0, but we'll be deleting that as part of that release. So we have this concept of wire stability as well. Right? This is the peer-to-peer protocol over the network. And the goal of this is that peers can be upgraded independently and continue to talk to each other over the network, even when running different network versions. And we've got some work remaining to do that. We're in the middle of switching from Cryo, which has always been temporary scaffolding sort of serialization, to our own AMQP-based serialization engine. The new engine is basically done, or largely done at this point. And in fact, there's a pull request open right now. It'll probably go in this afternoon to add a command line flag to switch well on the wire instead of a Artemis specific protocol. That's also being worked on now. That's turned out to be harder than you would think. I mean, message queue brokers should really be able to connect to each other with AMQP, but sometimes it turns out they can't. But as part of the work we're doing there, this is also part of the feature that some people have requested, which is sort of being able to use other MQ brokers as well. Finally, the network map protocol that we've been using up until now was never intended to be more than temporary, and we've designed a new one. We've been implementing it. That work is underway, but it probably isn't going to make it in time for the end of September. We'll see how things go, but it's probably only going to be half done there. We want to switch to a new network map protocol to increase robustness, high availability, decentralization, and a whole bunch of other things. There's a design document available for that, which I believe is on Discourse. In fact, I'll check after this talk, and if it isn't, I'll copy it there. There's another aspect of wire stability, which is RPC, of course, so nodes can be upgraded independently, and old applications talking to it, which are using old RPC client libraries, continue to work, and this shouldn't take very long. Right? RPCs already have some versioning support in them. The bulk of that work is, again, switching to a more stable and robust serialization system for the long run. And then finally, we just want to have one, go over it once, review it, and make sure that we've got everything we need to evolve it there. So there's not most of this work is, of course, the same as for other aspects of compatibility. Database migration, of course, from one to another is essential for any kind of production deployments. The goal here is to offer migration scripts as part of each upgrade, so you can do a backwards compatible database schema upgrade before you upgrade the node itself, and that's done at the time of your choosing. So current work, again, because we store binary protocol messages in the database in some places, we need to complete the switch to our own serialization mechanism. We're also finishing porting our code to Hibernate. Most of this work is done already. We did experiment with other database abstractions during Corda's development lifecycle till now, but eventually, some of those other abstractions looked initially good, and then just turned out to not be as mature as Hibernate. So we're going back to the devil we know, and some schemas I don't think this is implying a lot for schema change, but we might as well finish it first. And then finally, we would need automated testing to ensure that you can upgrade, potentially also downgrade as well. And the database migration scripts, probably using a tool like Flyway, will be able to do that in both ways. And the node makes sure there's safety checks to make sure there are no mistakes made, things like that. Finally, we've got this notion of binary stability, right? Java, the platform, offers both source compatibility, so your code compiles, and binary compatibility as well. In fact, the stability of the Java platform actually offers more binary compatibility than source compatibility, right? The Java language has broken source backwards compatibility a few times in the past, like when the assert keyword was introduced. I believe enums did that as well. So, but old jars that were compiled, old class files continue to work. Now we're doing it the other way around. We're offering source compatibility first. Until we've nailed down binary compatibility, you might have to recompile your app across node upgrades or from time to time. Of course, this is kind of a pain, and we want to commit to ABI stability as soon as possible. The work remaining here is really actually, it's not so much work that we have to do, it's more putting in place the right checks and processes in place to make sure we don't do this by accident. In particular, there's a large class of changes in both Java and in Kotlin where the source code will continue to compile, but the way it's compiled to class files has actually changed incompatibly. So it's really just about putting tools in place to make sure that we realize if we do that, and making sure that the team has enough training documentation so that we know what kind of changes we can make and which other kinds are not possible to make. For example, adding a parameter with a default value is something that isn't supported by Java, and you can do in Kotlin, but the way the Kotlin compiler turns that into class files means that it's not compatible from the Java side if you do that. All right, so platform versioning. We're introducing a versioning scheme that's basically very similar to the Android versioning scheme. Android versioning is simple, well-designed, and it's flexible, and I think it's the way versioning should be done. So the way this works, for those of you who haven't done Android development, is straightforward. The platform internally versioned using a single incrementing integer starting at 1. So as far as developers are concerned, there's only one kind of version number, which is a single integer. There's no like 1.2.3.4. Sticker versions, right, what humans might see, Corda 1.0, Corda 2000, whatever, those are for human consumption only, right? They're sort of marketing labels. And in the same way that Android uses these sort of cutesy names of candy and things. We probably won't be naming Corda releases after chocolates. Those in their jar manifest platform version, so that the node will check and refuse to load the app if the minimum version is higher than the current version. There's also a concept of a target platform version, which is one of the most useful concepts in this scheme. So the target version is used to control bug workarounds and potentially risky behavioral changes. This is one of the ways in which we plan to make the platform forgiving to developer mistakes, because I wrote software for desktop Linux for several years, and there's nothing more joyful than having your app broken and then be told it's actually your fault because some reasonable assumption that was made turned out to not actually be in the specification. You set the target version to the latest version of the platform you've tested the application with, right? So if your app only needs version 1, but you've tested it with version 5 using these integer versions here, then you set minimum to 1 and target version to 5. And this can, and here's an example, an imaginary example of what sort of thing this is useful for. Imagine we have an API called get the foods, and it returns a list of food. Very, very, very common API compatibility issue, right? You see this sort of compatibility issue come up all the time. The API does not specify the ordering of the results in the collection. And you can imagine, we have version 5, again, with integer versions. The list happens to be sorted alphabetically, right? Or sorted in some way. But that's just a side effect of the internal implementation. There's no guarantee in the Java doc that that's actually the case. And so in version 6, we go and do some more optimizations, and the function gets a lot faster, but the results now come in random order. And that's fine. We never guaranteed the order. But testing reveals that a few developers noticed, in fact, the old behavior, and they, they said, why would I bother sorting things myself when it's already sorted so helpfully for me? And they relied on that ordering, therefore, upgrading the node would cause an application compatibility issue. The solution here is fairly straightforward. If we become aware of this problem during the development period of version 6, we can look at the app's target version. For example, we can walk the stack when get the foods is called. We can check what the version of the app that's calling us is. And if the target version is less than 6, we can sort the results. So apps have the old expectation there. And if the target version is greater than equal to 6, then we skip the sort and we return in random order. Therefore, the apps can benefit from the higher performance, right? So we are not, this is not a technical break in backwards compatibility, but this is a way of helping out developers who may have relied on things that weren't quite actually guaranteed, which inevitably happens. And there are a bunch of cases like this, ordering example from Windows and Linux, the history of these operating systems. Finally, of course, Corda is building on the JVM platform. the JVM specification, in fact, and that specification is effectively incorporated into our own. Therefore, upgrades to Java would be synchronized with a new platform release and a new platform version number. So you can depend, if your application requires Java 9, when we upgrade to that, then that'll be something you can express through the minimum version in your app metadata. Finally, we've got protocol versioning, right? The bulk of the Corda protocol is flows. Of course, there's a little bit of other stuff like flow session management, but the bulk of the Corda protocol is defined by your own flows and the system flows we provide. Flows have their own version numbers defaulting to 1 if you don't provide one. This is implemented today. It's already in master, and we have a get flow context API which you can call within a flow, and that lets you discover the name of the application that you're talking to and also the version of the flow running on the other side. So this means if we want to like insert new messages halfway through this protocol, you can very easily test that to see like, will the other side understand my messages? You just use an if statement to upgrade the protocol there. And that's good. It means you can incrementally deploy new versions of the protocols and changes to message formats and so on. Talking of which, message versioning. Okay, so our new serialization engine, which we've been talking about for a little while, is designed with schema evolution in mind. Messages are self-describing. Messages are encoded in binary, and the schema itself can be represented in binary and is in fact included in the message itself. So messages are self-describing in the same way that XML is, but the schema or the information you can get from passing the message actually includes Java level type information too. So this is actually used, for example, in the engine. If you deserialize a message and no class for it is found on your class path, the engine actually synthesizes a class on the fly based on the schema information found in the message, which means you can then reflect over it if you're in a statically typed language like Java or Kotlin, or if you're using something like Groovy or Python or something like that, then you can just use it as if it was a regular object. So if there's a mismatch between the serialized schema and a class that's found on your class path that we would want to map it to, then this triggers an evolver. And there's the current evolver code, which is, you can find this in the pull request queue. It's being reviewed at the moment. Can handle things like adding nullable members. And the Kotlin type system is super useful here, of course, because the compiler will check that you haven't incorrectly assumed you will always receive this new version of the protocol. You can also add non-nullable members if they have default values provided. And you can do things like reorder members, remove members. We might add support for new evolutions in future, like changing types of things, changing the names of things, and so on. And because the schema is available, we can actually do quite sophisticated data format evolutions. This is, again, like everything in Corda, it's designed to integrate deeply with the JVM type system so that when you're building on top of this platform, you don't have separate IDLs or tools, which don't integrate nicely with your workflow. You just define the message types using regular Java classes or Kotlin or Scala classes, for example. So despite the fact that this is, deeply integrated and usable with Java, in fact, the serialization mechanism is designed that we can turn it into a specification in future. And, as this thing matures, we'll probably break it out into a separate library, a separate project on GitHub at some point, because, self-describing proto buffer, similar to Google protocol buffers, self-describing binary messages are a generally useful thing that many projects can benefit from. And this one has some neat features that go beyond what is out there in the market today. And it's easy to use as well, right? Like I said, we reuse your existing languages rather than inventing our own interface definition languages. And what we'll probably do to open this up to non-JVM runtimes, we'll, of course, doing this as well, probably starting with translation layers to text-based formats, so you can go to and from like JSON and XML and things like that, and then eventually we may implement versions that run on other runtimes as well. Kotlin can compile to JavaScript, which will probably help with that. So final note, planning. So Corda is a unique platform. The design is not the same as other platforms that are out there. Therefore, we're deep in uncharted territory with this platform, right? And moreover, we're going even deeper in future with things like the integration of SGX. So how are we trying to plan out that future and make sure we're not boxing ourselves into a corner with these compatibility guarantees? That's something that I've been looking at a lot lately. We're doing it through a couple of ways. One is that we're compiling a large, well, it's actually an Excel spreadsheet, right? A large table, feature matrix in which every square is an interaction of one feature with another feature. And this is useful to force us to consider how every feature interacts with every other feature. And often the answer is they don't interact. But in a complex design like this, there are interactions between features which have to be considered, and that's a good way to make sure we didn't forget about any. Finally, I posted the first one yesterday. We're writing a set of evolution plans, which are mini design docs for features that we know we want to add in future. They're not full design docs. They only consider how the API and protocol might have to be changed or extended. So the idea here is to convince ourselves that we can add the features we want to add without violating these compatibility guarantees. So that's what we're doing. I hope that explains why there's been less exciting news about features in recent times. And that's what I have for you. So thanks you, and let's see if there are any questions.
And if you can use the Q&A window for your questions, it'd be great. Then we can see that. And Mike, if you, on the bottom of your screen, you should see a Q&A window there for people to be adding questions.
I see it. That's great. Maybe there are no questions.
No problem. All right, so while we do that, we can wrap up. So it's a little bit of a shorter session, so I appreciate it. Apologies for the technical glitches. We'll work these out as we continue in this. So thanks for your time, everybody. We'll stay on for 1 minute to see if there's any other questions. Otherwise, we'll catch you in 2 weeks at the next AWG. Thank you, Clemens.
I will look at uploading this slideshow to our blog, so people who want to can work through it without the video.
Excellent. Thanks, Mike. There's nothing else. Thanks for your time, everybody.